Yeah, you're good.
Before we start, just hold off for a second. We'll just better have, are there any announcements first of all? Started?
Yeah. Cool. You're good to go.
Okay, well, thanks for coming along, everyone. Weather's not so great tonight. Now, what I was going to talk about is planetarium software, and I'm mostly going to use this program called Stellarium because it's a pretty easy one to use. It's free. It does have things like telescope control built into it. It's probably, if you're into doing astrophotography, it's probably not a tool you'd use for that. But if you're just doing visual observatory, then I think it would be fine. But we're going to explore what these programs can do, apart from doing that sort of thing like telescope control, exploring the night sky, that kind of thing. There's also some... Oh, can you do that? Or maybe leave these ones on. Just the ones over on Grant's side, perhaps.
Okay, is that the left or the right?
Yeah, I'm not sure. Okay. Hope we're not too much in the dark. Whoops, we're dropping cables off.
We got it. It's alive.
Okay, so there's a lot of these programs available, ones you pay for. There are mobile apps. I'm going to show you two desktop versions, and I'll explain why I'm going to go away from Stellarium at the end.
Oh, okay.
The first thing you have to do when you get one of these, you install it. Be careful installing any open source or free software where you obtain it from,
Yes.
Because there are some dodgy sites that have, hacked versions of it. So always download the stuff from the official site, or if you're using Linux like this machine, get it from a proper repository. So the first thing we have to do generally with any of these programs, unless you've got a phone one which has got GPS and it'll know where you are, so usually you have to tell the program where you are. Now, usually you would want it at your own location, but you don't have to. You can see what the sky would be like in any part of the world. So this one, I've already set it up for Auckland. This one's got a lot of preloaded city names in, or if you want to be more precise, you can enter your latitude and longitude of your house, whatever you want to do. So we'll go out of that. The other thing is the time. So I'll drag that up a bit so it's nearer the middle of the screen. So this particular program, you can put in the Julian date. I don't really know why they offer that, because it's not something I imagine most people would use. You would normally just enter your calendar in the Gregorian style and the time. So you can go back a few thousand years into the past or into the future if you're interested in seeing what the sky looked like in ancient times or what it'll be like in the future, that kind of thing. Or just in a few days and different times of night when you're planning your observing sessions. So one of the things we can do is select a star off the map. That was just a random one, and it's giving us some details here. This program isn't as good for this as some of them are, which I'll talk about later. but it gives you some basic things. It tells you the type, the apparent magnitude. It does take care of atmospheric extinction. So, for example, it's telling us there that the magnitude is reduced to magnitude 3.16 because you're looking through 2.37 air masses, and that's just because of the altitude of the star above the horizon. The program automatically calculates that for you. The other thing, there's some technical information about the star, the B-V colour index, which tells you basically how blue or how red it is. So that can be useful information to tell what type of star you're looking at. And then you've got the right ascension and the declination. And you'll notice that I'm not sure how easily you can read that, but it gives it twice. Once it says J2000.0 and the other one says of date or on date. And you notice the numbers are slightly different. What is happening here, this is because of the precession of the equinoxes. So basically the coordinates in the sky as used in astronomy, which is declination and right ascension, they don't stay static over time. And this is because as the Earth spins, it's also got a slow wobble on its axis, which is a period of something like 26,000 years. And because the coordinates are relative to the Earth's equator, things in the sky change with respect to that as the Earth is wobbling. So this is basically telling you when they publish catalogues and so on, they will have a specific date. So the catalogue date is J2000.0 for the star catalogues this program is using. And then the program's automatically computed the precession that has occurred up to the current date, and that's where your second RA and DEC numbers are. Now, I probably should explain this if some of you don't know what this is. What I've turned on there is what are called equatorial coordinates, and you notice that they go to won't let me select it exactly, but it goes to a point in the sky that's, in this case, the south celestial pole. So the north and south pole basically anchor the coordinate system, or if you like, the celestial equator, which is the Earth's equator projected onto the sky, anchors one of the coordinates, and that one is called declination. So what you're measuring with that one is how far north or south of the equator the star or the point in the sky is. So obviously the south celestial pole will be 90 degrees south of the equator. Similarly, if we flip around to the northern hemisphere, it'll be 90 degrees north. So that's exactly the same way that latitude works on the Earth. And in fact, you can take an earthly latitude and just project it onto the sky, and it becomes declination. It's just a different terminology. Right ascension is a little bit different. That's these lines that are showing you going east-west, or they're moving east-west. And those lines are a bit equivalent to longitude. The difference is that longitude is fixed to a particular point on the Earth's surface in Greenwich. So you have a line of longitude runs through, I believe there's even a marker on the ground that they use for this, and everything in longitude is calculated relative to that, either degrees east or degrees west. In astronomy, we do something different, and if I zoom out and go around to the north, you can see that you've got this orange line, and that line is called the ecliptic, which is basically the path of the sun across the sky. So it effectively defines the plane of the Earth's orbit around the sun. So when we're sitting on Earth looking back towards the sun's obviously always going to be on that plane because the Earth is orbiting pretty close to a plane. It does wobble around a bit with a fairly long period due to the gravity of Jupiter and Saturn, but we don't need to worry about that. That plane defines the path of the sun as viewed from the Earth across the sky, and the reason it's called the ecliptic is because eclipses can only occur when the moon happens to cross the ecliptic at the location of the sun in the case of a solar eclipse, or directly opposite the sun in the sky for a lunar eclipse. Because the moon actually isn't direct, more of it is tilted to the ecliptic by about 5 degrees or so, so that's why we don't get these eclipses happening every month. Now, there's quite a lot of things that you can learn from these programs. One of the things is about I talked about the origin of coordinates on the Earth being Greenwich. For the sky, we use actually a crossing point of the ecliptic with the celestial equator. So I'm not sure how easily you can see that there. Actually, what I'll do is I'll bring up the constellations as well. So we can see that we've got a point where there's the celestial equator as the basically zero declination line, if you can see that running down there, and there's the ecliptic crossing. That crossing point there is basically the northern hemisphere autumn crossing, or the spring crossing for us in the southern hemisphere. Won't need to do it, but the other crossing is where the sun is going from south to north. That's called the eclipse crossing at that time of year, and the end of March is the one for the northern hemisphere spring. And that point in the sky is called the first point of Aries. And that's just the name they give to basically the origin point of the celestial coordinates. So the equator on the meridian, the Greenwich meridian for latitude and longitude is going to be 0, 0. And for the sky, that's that point in the sky where the lines cross. And although it's called the first point of Aries, the point is actually in the constellation of Pisces, and it's nearly into Aquarius. It'll eventually move into Aquarius, and that's caused by precession. So back when the crossing point was named, probably by Ptolemy back in, 300 AD, that crossing point, the first point of Aries, was in the constellation Aries, but precession has moved it into Pisces, and it's almost now moved into Aquarius. So that obviously changes the coordinates. The other thing about this right ascension coordinate, instead of using angles, astronomy uses time. So we have instead of 360 degrees for the full circle, we have 24 hours. And so the reason probably is time is a convenient way to do it, because, for example, you can convert right ascension into what's called an hour angle. For example, if a star is going to cross the your local meridian, which means the line going straight over your head from north to south, if the star is going to cross that line in 3 hours, then you'd say that its hour angle is going to be minus 3 hours. Or you can say 21 hours, depending on how you measure it, if you go all the way around the clock, or east and west. Some of these programs do it the 24-hour method, where you head west and then come all the way around to the east, and then something like 3 hours to the crossing would be 2100 hours. And then when it crosses, it'll go to plus 1 hour, plus 2 hours, and so on. So because when you're observing, it's quite useful to know when is the star you're looking at going to cross the meridian. It's useful to have it in time rather than in degrees. So that's the reason why time is used. So that's a bit of background on the coordinates, and we can see if we could select a star again, we can see, as well as those right ascension and declination, the program tells us the altitude and azimuth. And that's pretty obvious what that is. That's just the azimuth is the compass bearing around the horizon, and the altitude is how far above the star is above the horizon from 0 up to 90 degrees. And there's some other things that you can look into if you're interested. Gives the ecliptic longitude of date. That's basically how far along that east-west line it is from the sun in terms of angles. So, and you've got things. Oh, another thing I should quickly explain is you notice that it talks about sidereal time. And the reason is that if you notice as each night goes by, stars are rising earlier and earlier, and it turns out that that's about 3 minutes 56 seconds earlier each night. So if you work that out over a month, that's about 2 hours, and over a year it's 24 hours, and that's why as the Earth is going around the sun, you're going to see different stars in the sky, and the Earth's rotation takes a little bit longer to get back to where it was relative to the sun. So the sidereal day is a bit shorter than the solar day. Actually, has anyone got any questions about coordinates and things before we go on? Okay. So some other things, this program, you can, for example, bring up constellation line drawings. So, for example, we happen to be looking at Virgo here, and these are the sort of standard stick figure drawings that are used to give you an idea of why the constellation might be called what it is. You've got Corvus the crow there, Crater the cup, Hydra the water snake in this part of the sky here. And we can also turn on some other things like constellation art. And unlike in the planetarium where we can turn it on for just one constellation, in this program it's either all on or all off. So you can see some sort of traditional artwork. You can also go into the settings here, go to the sky settings, and we can select sky cultures. And in fact, the one we've got showing these particular artwork is, I think, is under traditional, I think it calls it, or Western maybe. But you can choose a lot of different cultures. We've even got some local ones here for the, if I get rid of that, I'll just get rid of that and we'll see what it shows a few local cultural, like the fishhook of Maui there. As far as I know, they don't have any, like an all sky representation, but some of them have more in them than others. You can explore different cultures just by selecting the one you want from the menu back here. For example, there's Hawaiian and various other ones. The other thing you can do in the menu here, there's a lot of options for markings. You can turn them off. In here we can take off the equator, we can take off the ecliptic, for example, and you can see there's a whole heap of options for the different grids that you want to apply to the map. So there's a lot of things to play around with in here. Under the sky, under the general settings, you can fiddle around with the Milky Way brightness. And you can tell it even to display the zodiacal light and how bright you want it. So there's a lot of, you can turn star twinkles off, and it's even got, I think, you can have spiky stars if you want them. Don't worry about that. There's a whole lot of things, like you can get it to notice double stars in particular. And down the bottom here, you have the type of projection. Obviously, you've got to do some kind of projection because the sky is a sphere and we're projecting it onto a flat surface on the computer screen. And this one here, we're just doing the default stereographic projection, but there's a number of other options. I believe this program can be used if you have a projector to project it onto an actual dome. So you would want to choose a suitable projection for that. And then we can mess around with the way the solar system objects are displayed under this menu, and ditto for deep sky. You can tell it which catalogues you're interested in. M for Messier, IC for the index catalogue, NGC catalogue, and there's a whole heap of other catalogues you can select if you're interested in exploring those. Tab for we already did the markings. The other one is kind of interesting, is the landscape, because you can customize this for yourself. If you've got a fixed observing site, or particularly an observatory, you can actually put your own horizon in with trees and all the rest of it. And I know some people who use this program do that. But you've got some, if I apply this one, for example, and zoom, whoops, I probably have to turn off the, hang on, go back to the sky and the culture. Where were we? Sky culture. Oh, it just took a while to come up for some reason. Yeah, so let me just change that again. And we'll go to the landscape. I think that's the default one they use, and you can see that it draws the ground in, and so you've got some buildings adjacent to the sky art. I'll turn that off actually. So this is a particular site in Geneva, in the countryside, that somebody's put their own horizon in, but it's basically provided with the program along with a number of others. And you can load stuff from various deep sky surveys. So I won't actually do that, but if you've got enough disk space, you can load all sorts of catalogue extensions into this program. Some other things in the setup you can do is this window here, astronomical calculations. You've got a number of things you can do here. There's ephemeris of objects. This is useful for comets especially, but also planets. You've got daily phenomena, you've got graphs. It can do eclipse predictions and data. But I was going to show this ephemeris one because we've got I mentioned earlier, there's a comet currently coming towards the inner solar system, which was predicted to be possibly naked eye brightness. But they've backtracked on that now because recent observation shows that the core appears to be breaking up. So it probably won't be as nice a comet when it does get into the inner solar system. But we can, for example, set various markers and so on, and tell it to calculate for us. Oops, we have to put a suitable end date. So let's go a bit into the future. And So the 31st of October. What is that? We've got 10 solar days. We'll cut it down to 5. And we'll calculate. So in fact, what it's done there, it calculates where the comet will be and its coordinates. And it also draws the path on the sky. You can see it's, from the Earth's point of view, it looks quite interesting, the path that it's going to take. So, and where you get this data from, we go back into this, again back into the settings, and we go into plugins, and then scroll down to Solar System Editor, and we can configure that, and then we can import orbital elements in MPC format. So we can, it's got built-in bookmarks, but you can, anywhere on the internet that provides these things, we can say MPC's list of bright minor planets. Oh, we didn't want that, we wanted comets. So we go to the list of observable comets, get orbital elements, and it's done them, and we can say, yes, we want all of them. And you've got an option of either overwrite or add new and update existing, or update only the orbital elements options. We can add, and it's updated its database. So that's how you pick up any newly discovered comets as soon as they're reported to the Minor Planet Center database. You can just include them into this program. And with comets, the orbital elements might change over time as more observations are done. Because of the outgassing that from comets, it actually acts as like a rocket motor on the planet, so it does alter its path slightly, just from all the debris being thrown off. Okay. I'll go back into this and actually tell it to get rid of that stuff. Because the next thing I wanted to do was deep sky objects. I already showed where you can set there's some settings for deep sky objects in the configuration menu, but we can also turn them off and on the actual display. So to do that, you can see that icon down the bottom there, that looks a bit like a spiral galaxy. That's basically turning on deep sky objects. And we can now see we've got some objects coming up on the screen. And just a little thing about the symbols for these. And this is fairly common on not only in programs but also on printed sky charts. A circle like that with a cross on it is a symbol for a globular star cluster. So if we go into the Milky Way, we can see there's a number of other symbols here. So if we see an open circle like this one here, if you can see that highlighted, as an indication of an open star cluster. So if you don't know the difference, globular clusters are basically all ancient star clusters that have a lot of members, so they're basically gravitationally bound to each other, and the clusters are massive enough that they basically stay together. And these are all in basically orbits around the core of the Milky Way, whereas the open clusters are much younger, and they generally have a lot less stars than the globulars, and over time they will end up dissipating through the galaxy, depending on the orbit there. And some of them do last surprisingly long times when they computed the age of some of these open clusters. Most of them are quite young, but there are a few that are older than you would expect because the orbits happen to not let them spend too much time passing through the disk of the galaxy. The green square boxes there are emission nebula, so that's the symbol for those. And then you can see in this program it has a little yellow outline there, which is showing a star cloud. So, and if you zoom in, you should see that more and more stars appear, and we also get some other objects. Point this one out, since this is a symbol we haven't seen so far tonight. This is I'm not sure how easy that is to see. It's not making it bigger. I'll bring it into the centre. It's basically a circle with 4 little lines attached to the outside. So that symbol is for a planetary nebula. So what those are is basically stars like the Sun that have run out of their hydrogen fuel. They basically had a last gasp, thrown off their outer atmosphere, leaving a white dwarf behind. And basically what the planetary nebula is basically the atmosphere of the star that was thrown off. Eventually these things will dissipate and you only have the white dwarf remaining. But they're kind of objects of interest for the nebula they have around them as long as it lasts. They have a lot of, if you haven't seen images of them, some of them have really complex sort of shapes and obviously interesting things going on with them. Didn't mention planets, but if I change the time to somewhere where we've actually got some planets, let's go, whoops, click the wrong thing there. Go into the dawn, or before the dawn, so we've got a few planets of interest. Come around to hopefully it'll show us some planets. Have I not got them turned on? That's probably why. Oh yeah. Planets are turned off, so that's one of the things you can do in this program. So I'm not sure, it's still not sure. Oh, there we go, it's showing Saturn here. Now we can centre it. And let's zoom in, and some of this program will actually render it. What's interesting here, you notice that the rings are almost edge on, and in fact that is slowly occurring. That won't be too far before the rings will be very difficult to see because they'll be edge on towards the Earth. And the reason for this is that Saturn and its rings has seasons just like the Earth. And funnily enough, the obliquity is not too far different to the Earth. Jupiter's different. Jupiter has virtually no seasons. The rotational axis is not exactly, but much closer to being orthogonal to its orbit around the Sun. But Saturn is a little bit like the Earth in that respect. So what happens is as the planet goes around in its orbit, it goes through seasons and the rings will be tilted at different angles towards the Earth. We could actually investigate this actually. What if we, whoops, I didn't mean to do that. I've unselected it, hang on. What I wanted to do was let's go time and let's go forward, say, trouble is it's below the Earth's surface now, so let's go to next year. And you notice it's got even more closed up. Saturn's orbit, of course, is roughly 30 years. So if you divide that by 4, that's more or less the length of a season. So there's about 15 years between the rings being edge on to the Earth and the next time they're edge on. So at one point the rings are tilted one way towards the Earth, the other part is tilted the other way. So let's try going another year, 2026. Oh no, they're opening up again. I must have jumped past it. So if I can, 25, 24. It's still not quite here, John. Oh, did it jump over there? Yeah, I think we need to... yeah, the trouble is it's gone into daytime, so we'd have to change our time of day as well. Sorry? Oh yeah, I could do that actually. Let's do that. Can we turn the ground off on this menu? Yes, we can. So let's sort of explore this. So, so it's about March next year. Now, Saturn will be in not a good position for observing in March anyway. So, but if it was, you'd basically see the rings nearly edge on. Okay, that's a pretty reasonable overview of this program and the sort of things you can do. The other thing I didn't mention, if you want to find an object and you're not sure where to look on the map, for example, we could put Venus or something, and it will click find and it will take us to the planet. So, it doesn't recognise all the common names for things, but it's not too bad. Some programs are better than others. Like if you put in an NGC, something like NGC, that will always work. Or if we go to, for example, a Messier object, whoops, wrong one. It shouldn't have any trouble if I say for M6. Yeah, so you've got the find, and let's try a name. What would be an example? Jewel box. Oops, spell it correctly. So it's already suggesting Herschel's jewel box is what it is. So if we zoom in, we should see the jewel box cluster. And so if you're really using it to learn the sky and you're not sure where this is, you just zoom out and you can see that it's right by the Southern Cross. We can actually, I'll turn some of these grids off to make it a bit easier to see. And you see it's got the names of a lot of the common names that it brings up, as well as NGC numbers. I might leave it at that for Stellarium. That's a bit of an overview of the sort of information that's in here and what you can do with it. Oh, one thing I didn't explain, I showed you one of the plugins, the Solar System Editor. This program has got a heap of other plugins. And one of the things you can use is this. If you were doing imaging with a camera, you can configure this to show you your camera field of view that you'll see with a specific telescope.
Very handy.
So that's quite handy. You can also do it with eyepieces. This will show you the view with a particular eyepiece. So you tell it what the telescope is. In fact, it looks as though this is selecting some kind of binoculars. Yeah. Yep.
Can we change eyepiece or telescope configuration here?
Yes. You don't do it here. You actually have to go into the menu. You go into this thing, like it looks like a spanner. And then you go to find it's called oculars, and then configure it, and you'll find it's got a whole lot of eyepieces built into it, but if it's not one in the list, you just tell it the focal length of the eyepiece and the apparent field of view. And similar for telescope, on the telescope tab, it's got a whole heap of scopes built in, but if what you're after isn't listed there, you just tell it the aperture and the focal length. and then it knows how to compute the field of view of the eyepiece as seen on the sky. And ditto for the cameras. You can configure the camera sensor, and it's got a few. They all look like DSLRs rather than real astronomy cameras, but you can put the details of whatever camera you're using in as well. I'm going to go out of this and just quickly look at another program. Oh, what's this done? Has it killed me? Oh. Yeah. It's a bit strange. Yeah. Okay. All right. That was a bit weird. It's doing weird things now on my screen, but not on there. I think it's settled down now. I don't know what it was doing for a minute. The colours were changing weirdly. Anyway. I've not got it on here. Maybe I can't show it. I won't worry about that. I'll just tell you about it. I don't think I forgot I didn't reinstall it. There's a program, another freeware program called Carte du Ciel or Sky Chart, and it doesn't render the sky as well as Stellarium does. But one really useful thing that it has, it allows you to select specific catalogues, and you can even select the Gaia satellite catalogue from the Gaia satellite and all of the US Naval Observatory catalogues. So it's quite good for that sort of thing. And the other, if you actually prefer to have a printed chart, then it's really good for that, because if you print a chart, or you can do a screenshot out of Stellarium and print it, but it's going to waste a heck of a lot of ink because it has a solid black background. So what Carte du Ciel will do, you can generate charts for printing, and then the background will be white and the objects are going to be black or other colours. So it's a lot more feasible for that sort of thing.
What's that program?
Sorry?
What's that program?
Oh, it's called Carte du Ciel, because the guy wrote it as French, but it's also called Sky Chart. So if you look up Sky Chart on the internet, you should find it. The other thing, my laptop is doing something really weird here, so I'm actually going to reboot it.
Yeah, that's probably a choice. It might just be a bit confusing.
It's got messed up with the display somehow. The other thing I just wanted to show before we finish is one of the phone apps. And what I'm going to try and do, I wanted to reboot because I don't want any weirdness happening, because what I want to do is actually capture the phone screen onto the laptop.
I've been trying setting that up on the
Hopefully it'll work. Got to make sure they're on the same Wi-Fi network. So just, I didn't get a chance to check that before.
They might not be on the same one.
Okay, here we go, connections. Oh, okay, no, it isn't at the moment. I'm going to take it off that network and put it on the same. There's more than one Wi-Fi network in this building, so I want to make sure they're on the same network so they can talk to each other. Okay. Connect. Okay, let's see if we can get this to work. Just log this back in again. It was strange because it seemed okay on the big screen, but it was doing really weird things on the laptop screen. Yeah. Yeah, rebooting it seems to have fixed it. So what I want to do, there's a program called AirDroid I'm going to use.
AirDroid.
192. Okay. 10.0. 192. So I'm basically connecting to the phone. Ah, damn. Oh. Try that. Oh, here we go. That's got it. Right. So basically what we're supposed to be able to do, that you can do various things on here, but we should be able to, if I find the right setting, under mirroring, and I'm not sure, get rid of that stuff.
Welcome to the Reese class subbrief. The Reese class submarine is built by Turkey.
We'll forget about that. It won't let me maximise it. I was trying to get it as big as it will go. I have to give it permission, so start. Okay. I don't know how good that's going to be because it's pretty small. Is it big enough to see? Oh, we can. Oh, that's a bit better. Does that come up okay on your?
Yeah, as good as it can be.
Okay. I don't want that stuff. Okay. Let's try now to get the application going. Sorry about this. I didn't have time beforehand with the other session going to check this out.
You just need to find the program, right?
Yeah, I was going to use Sky Safari.
Yeah, that's a good one. Actually, AirDroid works surprisingly well.
I don't want to rate the program now, thanks. Oh, it's got another allow. Okay, so you can see basically, obviously a much smaller screen, but it has the same sort of features. We can select the time down the bottom. You can see if we want to go now, and we can, at the moment, it's going forward in time in 1 minute intervals. Oh, what's that saying? So we can change that to specify whether we want hours, days, or months. We could say hours to change the increments, and then you've got this to go forward 1 hour at a time. Obviously, you can drag around the screen. We select objects, and this one is pretty good at information. We go selection and then object info. And it gives the same sort of information we're seeing on the screen in Stellarium, but it actually is a lot more. And for a lot of objects, it will have a text description as well. And some of them go for several pages. So it's quite a good program. Unfortunately, this particular one isn't free.
They do have
There might be a free version with lesser features, yeah. One cool thing you can do here, which is a bit crazy, you can fly out to the object. You can do the same with the planets. Now we have to find the thing to get back to Earth. Somewhere there's a... Where's the Earth gone? There's the thing. Oh, there we go. So we go back home. We've got our super starship. Flew 300 light years in few seconds. So yeah, this program is another quite a good learning tool. It also has telescope control. Some of the mounts have a Wi-Fi adapter you can get that will talk to this program. And so it's quite powerful. It's got, again, you've got your search functions where you can just type in the object. It also has a tonight's best, so it gives you if you're not sure what might be up, it gives you a bunch of objects that might be of interest to you, and then we can select it, and it'll take us to the description of it, and then we go center, and it locates it on the map. So it's quite a nice program. One thing I found a bit annoying about it, when they have a major update, unfortunately you have to pay again for the new version. So I haven't bothered to upgrade to the latest version. So this isn't the latest one we're looking at here, but it's still a pretty good program. The other thing that a lot of these mobile apps can do, and this is quite a cool feature, especially for new people starting out in the hobby, is this compass mode. You see what's happening here. So you can look at a star in the sky and it'll show what you're looking at on the map. So that's quite handy if you're looking at something you're not sure where you're looking, what it is you're looking at in the sky. You can use this program, just aim it, and it uses its tilt meter plus its GPS coordinates to know where it is on the Earth, plus the tilt. I think to get good results, I think the phones in their settings have a method of calibrating the tilt meter. Okay, we might close out of here. That's about all I wanted to talk about tonight. I was going to show you cart to seal as well, but it looks like I didn't have it installed on this machine, which is a bit of a pain. Never mind, you can investigate that yourself. So I guess just are there any questions about sky charting programs? We talked about astronomical coordinates. I hope I didn't confuse everyone about that.
There's no question online, so just whoever that has questions.
There are free phone apps as well, apart from Sky Safari. Does anyone have any favourites?
I think Sky Safari is probably the best one, though.
But that,
Because
You can get Stellarium on the phone as well.
Oh, there's a phone version of Stellarium. Didn't you have to buy that, or there is a freeware one? Okay.
Google has one as well.
Right.
And it can't see elevation, which I found out to my chagrin.
Oh yeah.
Further, ESWC is called Astronomy. It's also a planetarium program, like on a cell phone, but it has the added advantage that it's designed to be put on the telescope cube, lying flat, self-aligned flat on the cube. And then the planetarium program, once it's calibrated, has the capacity not only to show you what's up, but lets you point your telescope with a go to push to.
Oh yes, Sky Safari does that as well.
And Astrohopper does that. That's another really good option. Astrohopper.
That's cool.
So that's a free one, so that's good to know.
Yep, and very, very good. Takes any telescope, makes it copy
Then there is one night sky that also has that compass enabled live view.
Right.
Yeah, it's free.
Yeah. The compass is probably, once you get familiar with the sky, it's not something you would use quite so much.
Yeah.
But although sometimes if you're in a place you're not familiar with and the sky's got a lot of cloud and you see a clear patch, sometimes you can get a bit disoriented and think, oh, what's that there? And your phone is quite handy for that sort of thing.
Yeah, for sure.
Yep.
For one ascension, how does that map to the time of day in terms of sort of a 0 hour? Like it's the ecliptic crossing the equator, so does that mean that's 12 o'clock and 0, isn't it? At what time of year would that be due east or due west?
In the spring, not our spring, the northern hemisphere spring called the vernal equinox. At the moment of the vernal equinox, the sun is on the 0 position in the sky. Right. So 0 declination, 0 right ascension.
March.
Yeah. But that may not be during the day for us. No. Depending on how close you are to a leap year and that sort of thing, the actual position relative to where you are, where that happens, it could happen during your night when you can't even see the sun. But I mean, by the time it's daylight and the sun rises, it's not going to move that far off the position in that time, because it takes 365 days to do a full circuit. So in a few hours, it isn't going to be very far.
But here in New Zealand, that would be what time of day?
Can be any time of day. Because the Earth's rotation is different to the sidereal time, so it's going to change. And you've got also the wobble in the Earth's axis is affecting things as well. So the 0 point is changing in the sky over time relative to the distant stars. Yeah. One thing I was going to mention, with both of these measurements, like you might have wondered why, like angles, we measure in like 360 degrees, and in time we have like 60 minutes to the hour and that kind of thing. And you can blame the Sumerians for it actually, because that they use that as their numbering system, base 60, and that was learned by the Babylonians, and they passed that on to the Greeks and Persians, and it's basically really ancient, the idea of breaking the circle up in those base 60 type schemes goes back probably 5,000 years. The Sumerians were pretty clever, and they were really keen on observing the sky, and they passed a lot of that on to the Babylonians, who picked up their writing system. So they were probably interested more for divination purposes, because the rulers wanted to use the sky to, for omens of when it was a good time to go and beat up their neighbours and that kind of stuff. I'm not exactly sure, but I think it's also it possibly goes back to the same origin, because it's 60 is a multiple of 12 and a multiple of 5, multiple of 6, 3, and it's got a lot of 10. So they like that number because it has a lot of factors.
Even why not 60 hours in a day?
That I'm not sure about. Yeah, probably have to. So are there any archaeologists here or historians might be able to tell us?
Well, it's basically taking 60 divided by 10 and then having 4 quarters. There you go.
Yeah, their numbering system is really interesting. I don't know why the Greeks and Romans didn't pick it up, because they almost had the number 0. They did have a placeholder for their base 60 system, like if you had 60 times 60, they indicated that with a placeholder, but they didn't quite get the concept of 0, the modern concept, which I think originated in India.
Looks like Internet says the 24-hour day was due to the Egyptians.
Egyptians, okay. Right, okay, so that probably, the hours probably had a different origin, but probably dividing up of hours into 60 minutes and so on was probably that way. Yeah. Okay, well, thanks for coming along, and it's film night next week.